Hello, I'm going to continue talking about the theory of interest. Today's topic is about nominal rate of interest and discount. The meaning of a nominal rate is actually in the name of this the word nominal means in the name of. It's not exactly the effective rate. So suppose we have a nominal rate of say 12% and compounded uh, monthly. So what it really means is that the interest will be calculated each month, with the rate per month is 1%, 1% per month. And this 1% is actually effective. So you multiply by 12, it's a nominal rate. That is not the effective annual rate. We're going to get to that later on. So the meaning of this I to the m, parenthesis m is this number, the nominal rate, divided by m will be the effective rate per time period. So that's the meaning of this number, period. Okay. M is the number of times the rate is compounded per year. The effective rate per time period is this, which I wrote it here. Sometimes we denote it by J. Okay. So if I is the annual effective rate, then 1 plus I would equal to 1 plus J. J is the effective rate per time period, which equals I to the m plus to the m over m. So that's the effective rate per time period. And then you have 1 plus j compounded m times, so raise the power by m. That equals 1 plus I. This relation should be very familiar for you. So I is the effective annual rate equals 1 plus j to the m minus 1 is also 1 plus I to the m over m to the m minus 1. And similarly, from the effective annual rate, we can get the nominal rate based on this formula. Okay. This m should be known. It's the number of times the rate is compounded per year. All right. Let's look at an example. So Sandra inherits $10,000. She deposits it in a 5-year certificate of deposit CD, paying 6% nominal interest rate, compound monthly. So for this one, M equals 12. At the end of 5 years, she decides to renew her CD for another 5 years. Then the at the then current nominal interest rate of 7.5 compounded quarterly. So here M equals 4. All interest is left to accrue. That means the interest Sandra earns earlier will be accrued to the following time. The interest will be earning interest as well. So it's the compounding concept. So at the time her second CD matures, what's her investment worth? So we're looking for the total amount that she would have starting from 10,000. So the idea is to use the amount function, uh, amount formula, which is you have a principal, 1 plus I to the parenthesis m over m to the m times t. Okay, t is the number of years, m is the time the interest rate is compounded per year. So in the end of fifth year, she would have 10,000 times 1 plus the nominal rate, which is 6%, 0.06 over 12. And then you have a 12 times 5. Okay. That's the amount in the end of the fifth year. But then you're going to treat this as the principal for the next, how many years? 4 years, another 5 years, another 5 years. So the second 5 years. Multiply by 1 plus 0.075 over 4 quarterly, and 4 times 5. And you calculate it out. Okay. The answer, no, I just show you the answer. All right. The next question. Paul takes a loan of $569. Interest in the loan is charged using compound interest. Basically, it's a compound interest. The rate is compounded. 1 month after a loan is taken, the balance is 581. So 1 month, right? Find the monthly effective interest rate which Paul is charged in his loan, and then find an annual nominal interest rate compounded monthly which Paul is charged in his loan, and then 3, find the effective annual rate. So the monthly effective rate would be simply 581 minus 569 divided by 581. Okay, so it's the difference between the amount the loan the account has, okay, divided by the original loan. Okay, so you calculate it. That's called it J. Okay, so I'll show you the formula. I'll show the answer later on, but I'm gonna just talk about how to get this how to get all the answers. Give you the formula. All right, so maybe I should put it here. 581 minus 569 over 5. Sorry, it's actually 569. Okay, that's J. It should be 569, the original loan amount. That's our J. And then find the annual nominal interest rate. J is like I to the parenthesis m over m. So the interest is compounded what? So we're going to treat it as a compounded monthly. Okay. Yeah, it's compounded monthly. It says so. So you have a 12 here. That should be equal to 12 times J. That's our nominal rate. And the effective rate, we use the formula 1 plus I equals 1 plus J to the 12th. So I equals 1 plus J to the 12th minus 1. And you find J, and then you find I, the nominal rate, I to the parenthesis 12, and then we find effective interest rate, which is I. All right. You can check the answers like this. All right. Next problem. John takes a loan of $8,000 at a nominal rate of interest of 10% per year, convertible quarterly. Convertible quarterly means compounded quarterly. So little m equals 4. How much does he owe after 30 months? Uh, Notice the units is a month, so you only need to work with a monthly effect rate and then just compound it. So you have a 8,000 times 1 plus the monthly rate, which is okay. Actually, we don't know the monthly rate, monthly effect rate, because it's convertible quarterly. So the quarterly effect rate is, let's call it J, I don't know how to say J4 quarterly maybe. Uh, that's the quarterly rate, effect rate. That will be equal to 1 plus J12, that's the monthly rate, to the fourth. Okay, you have this relation. They are all effect rates. This is monthly, this is quarterly. A quarter has, sorry, to the third. Okay, 3 months, 1 quarter. Um, so J4 is uh, 10% divided by 4 because that 10% is a nominal rate compounded quarterly, so that equals 0.1 over 4. So I have this relation equals 1 plus J12 to the third. All right. And then you put this monthly effective rate here, and you have 30 months. So you can do that. So here the units is monthly. I think it's pretty relatively easier because you are dealing with monthly rate, effective, okay, effective monthly rate and 30 months. All right. So another way of looking at it is actually 8,000 times 1 plus J sub 12 to the third is 1 plus 0.1 over 4. So you would have this thing. It should be the same. Uh, or you can say 30 months is basically 10 quarters. Okay, this is the quarterly effective rate, and this is the total number of quarters in 30 months. All right, you can find that. The answer is given here. All right. All right. Let's move on. These examples are for practicing the relationship between nominal rates and effective rates at different time period. Okay, so first problem, I2, the parenthesis 4 equals 5%. So this nominal rate compounded 4 times a year, so it's quarterly. And we're looking for the annual rate. One annual rate is 1 plus I. That should be equal to 1 plus I to the 4 over 4. So it's quarterly rate. And each year has 4 quarters. So you do that. I equals 1 plus 0 0.05 over 4 to the fourth minus 1. Okay. Now, if effective rate is 5%, annual effective rate. The meaning of this notation is annual effective rate is 5%. And what is equivalent I to the fourth? That's the quarterly rate. So again, you have this relation. You find the quarterly effective rate and you compound it 4 times. That's 1 year. That's equal to 1 plus 0.05. All right, so then you can solve for I to the fourth. The parenthesis 4. That equals 1.05 to the 1 quarters. That's the root function minus 1, and then you multiply by 4. You can use the formula or directly solve this equation by algebra. All right, let's introduce the concept of nominal rate of discount, D super parenthesis M. Uh, Similarly, we have this relation. Okay, remember for the uh, interest rate, we have this 1 plus I, you're accumulating, all right, interest, 1 plus I equals 1 plus I to the sup M, the sup parenthesis M divided by M to the M. So we have this relation. And for discount, we have this relation. This is the nominal rate divided by M. So this will be the effective discount rate per time period. That's what it means. Okay. So this is a effective discount rate per time period. All right, and what we can sort of illustrate how the compounding of discount rate of nominal discount rate and nominal interest rate they work. So uh, I'll show you this timeline. Okay. Say we have 1 year. So it's 1 year. Starting from one, you have 1 year. 1 year equals m time periods. So m periods. That's 1, 2, dot, 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 and then you have m minus 1. Okay. Say you have $1 at the beginning, so you would compound it by you will get 1 plus I this thing. That's how much money you would get in the end of the first time period, and this one you would have 1 to the I super m over m, then you squared it, and eventually you would have 1 plus I sup parenthesis m over m to the m. So this is the money you would have in the end of 1 year, which is 1 plus I. And then if you have $1 in the end of 1 year, then you're going to discount back by multiplying that number by 1 minus d sup m over m. And then you discount back and discount back. So this one would be 1 minus d sup m divided by m squared. And then you discount back until this one, you would get 1 minus d sup m over m to the m minus 1. And then finally, at this point, you would have 1 minus d sup m over m to the m, which is exactly 1 minus d. All right. So you try to understand the mechanism of these compounding schemes. Once you understand it, it's not that difficult. Many formulas, if you understand them, then they are relatively easier to remember and to apply. Just memorize them, it's not very ideal. Okay. We learned this identity a while ago. This works for effective rate. So D is the effective discount rate. I is effective interest rate. Okay. Here D is like annual, I is also annual, but this relation also works for effective rates at any same time period. For example, here we have there are m time periods per year. This is like for each one time period, and this is the effective discount rate per time period. This is the effective interest rate per time period, and they do have the same relations. So 1 minus the effective rate times 1 plus the effective rate. I mean, the first one is discount rate, the second one is interest rate. They have the same time period, both are effective. Then you have this relation. For nominal rate, the relation usually don't work. It doesn't work like the effective rate. When m equals 1, then obviously it's just one special case of m equals 1, then dm, im would be the effective rates. Okay. Let's practice about the relation as well. These things are uh, very confusing if you don't understand the basic concept. Because there are four things. You have a nominal discount rate, effective discount rate, and then you have a nominal interest rate and effective interest rate. And for effective interest rate and effective nominal rate, sorry, effective discount rate, you also have a annual rate versus rate per time period. So that makes the problem a little bit more, these problems more complicated. But remember the relation, this relation works for effective rate. Either it's annually or per time period, that doesn't really matter, but the key is that they have to be effective rates. All right, so we have this problem. We know that this nominal discount rate is 5%. We're looking for annual effective rate. Okay. Uh, so you wanted to find the effective uh, quarterly interest rate using this relation. So 1 minus 0.05 over 4. So this is the quarterly effective discount rate. And then you do 1 plus j. J is like the quarterly. That equals 1. So you find J4 from this equation. And then to find the annual effective rate, you use this relation, 1 plus j4 to the fourth. That should be equal to 1 plus I. Okay, so I, you will be able to find I uh, from these two equations. Okay. So I'm not going to calculate it. The answer is here, so you can check that. Let me know if I made any mistakes. All right, so this I again is effective annual rate. We have a discount, nominal discount rate compounded 2 times a month. So it's like semi-annually. We use the half-year effective rates as the bridge. So I need to figure out the half-year effective interest rate. Let's do J sub 2, okay? That square equals 1 plus I. So for this, from this equation, I can get J2. And then you need to use this relation. J2 is the half year effective interest rate. And then you do maybe D2. These notations are not really standard, but this is effective half year discount rate. And then you multiply by 2, you get this nominal rate 2 times D sub 2. So this is a effective discount rate half year per 6 months. Okay. All right. Uh, the next problem, we have a nominal discount rate and compounded 4 times a year. And we have a nominal interest rate compounded monthly. They have different time periods, and both are nominal rates. Remember, we don't have the relation of 1 plus I times 1 minus D equals 1 for nominal rates, so that doesn't work. You can use monthly effective rates as bridge or quarterly effective rates as bridge. Either way. So let's do monthly. To monthly rates, monthly effective rates as bridge. Okay. So I need to figure out monthly effective discount rate. Okay. This number divided by 12 doesn't give you that number. Divided by 4 would give you the effective quarterly discount rate. But you still need to find effective discount rate per month. So you need to do this. 1 minus D, say, monthly discount, effective discount rate to the fourth, actually to the third, because we have 3 months. That should be equal to 1 minus the quarterly rate, okay? And the quarterly rate can be found very quickly from the nominal discount rate, which is this one. So that would be 0.046 over 4, okay? So from this equation, you would get D sub 12, which is the effective monthly discount rate. And then you use this relation times 1 plus J12, that's the monthly rate, monthly interest rate, effective interest rate. And you get this equation, you would be able to solve for J12 and J12 times 12, it will give you the nominal rate. Okay. Let me see if I can put them together. Uh, I hope it's not that bad. That equals 12 times J12. J12 equals what? Equals 1 over 1 minus D sub 12 minus 1. Okay. And 1 minus D12, that equals, I need to have a third root. It's on the bottom, so it's 1 minus 0.046 over 4. It's on the bottom. And then you raise the power by 1/3. It's the quarterly thing. That is one. This is this quantity minus 1. So we have this formula. Okay. All right. Let's work with quarterly to see if we can match these two formulas. So let's work with quarterly. So we're going to work with quarterly effective discount rate, effective interest rate. Okay, both are quarterly. So I have 1 minus D4 over 4, so 0.046, oh, sorry, 0.046. Divided by 4. So that is our, this is our effective discount rate per quarter. It's effective, so I can do this 1 plus J, that's quarterly, okay? That equals 1. And then I solve for J4. But then I need to You cannot simply multiply this by 4 to get I to the 12. You cannot do that. You need to get the effective monthly rate, and then you multiply by 12. Okay, so that's what we need to do. So 1 plus j sub 4, let's solve that. So 1 over 1 minus 0.046 over 4. Okay, so this is that's how to find j4. And then 1 plus j4 equals what? Equals 1 plus j12. The monthly rate raised the power by 3 because you have a 3 months. So j12 again equals just 1 plus j4. Take a third root. And then subtract 1. And then you multiply by 12 to get I sup parenthesis 12, which is this. All right. Okay. Um, so let's see, how can I make the situation clearer by drawing a graph? And the graph seems to be very complicated, but I hope you understand it. So you have a J sub m. So this is the effective rate per time period. And you have a relation like 1 plus j sub m times 1 minus d sub m. They're all effective. So this is the effective discount rate, d sub m. You have this relation. And you multiply by m, you would get the nominal rate. And you multiply by m, you would get the nominal interest rate. Obviously, you're going to divide this by m to get the effective rate per time period, interest rate per time period. So, well, you can do that. And similarly, you divide by m from the nominal rate to get effective rate. And these two, we don't have much relation, okay? So we don't draw anything here. And from Jm to I is our effective annual rate. So you have this relation, 1 plus I equals 1 plus J sub m to the m. Okay, that's the way you find I. And similarly, you have the effective annual discount rate. You do 1 minus d sub m to the m, that equals 1 minus d. Okay, and then these two, you have a relation that 1 plus I times 1 minus d equals 1. Okay. All right. So this is a nominal. Okay. And this is a effective. Okay. All right. Let's see. Move on. Generally speaking, assuming I greater than 0, m greater than 0, I is again the effective interest rate, and then m is the number of times it's compounded per year. And we have this inequality. The year annual effective rate is always greater than or equal to the nominal rate. Okay. And then the nominal interest rate is always greater than or equal to the nominal discount rate. And then nominal discount rate is always greater than the effective annual discount rate. So you have this kind of relation. All right, I think that's for the previous section, which is about nominal rates. And this section, I'm gonna use another recording. Okay. Okay. So that's for now. See you the next time. Bye bye.